Part 1 of 5.2, we are reviewing our basic exponent properties. The catch as you look is that our exponents are fractions. So we're reviewing the basic properties, but it's also using them in terms of fractions. So, kind of review. You've seen all these properties before. It's just you probably learned these properties back in middle school, to be honest. Let me rephrase that. I'm not going to use the word learn. You saw them in middle school. Whether you learned them or remembered them, different story. But, okay, so the product of powers. If you are multiplying two amounts and the base is the same, what's the rule? You're going to keep the base, and the shortcut is to add the exponent. Okay, so we multiply and the base is the same. Shortcut is to keep the base the same and add the exponents. What about division then? Quotient property says if you're dividing and the bases are the same, you're going to keep the base the same, and instead we're going to subtract. Okay, those are two properties. We use them all the time. We just got to remember them. Power of a power. This is, notice there's only one base on this one, and it's a power raised to a power. So we have a to the m raised to the n. When you have a power raised to the power, that is the place you multiply. So just one base, power next to power, you're actually going to multiply. Okay, this is kind of a variation, power of a product, and this is basically saying if you have ab raised to the m, this m goes on both the a and the b. Okay, it's just saying that, I don't want to use the word distribute because that's not what it is, but it kind of reminds us of that, I know. Okay. Negative exponents. We talked about this yesterday, didn't we? Okay. Anytime you're asked to leave a final answer, acceptable form is you don't leave a negative exponent. So if we're not leaving a negative exponent, we have to know how to get rid of it, and that's moving it across the fraction bar. So if we have a negative exponent, to make it positive, you move it to the denominator. Just the same, if you have a negative exponent in the denominator, where we're going to take it to make it positive, it's going to have to go up then. So moving it across that fraction bar changes it from negative to positive and vice versa. And zero property. Anything raised to zero is always 1. And if you forget that one, the calculator will verify for you. Okay, you type something into your calculator raised to the power of 0, it's going to be 1. Okay, so those are the properties we're using. Now, in middle school, you got to do the basics, right? Nice, neat whole numbers. We're using fractions. So let's look at A. 81 to the 5/6 times 81 to the negative 1/3. Don't worry about the fractions. Don't stress about the numbers right now. What's the basic rule? If it's 81 to 5/6 times 81 to negative 1/3. Okay, product of powers. The base is the same, yes. So that means we keep the base the same, and since it's a multiplication problem, we're going to add the powers. So I'm going to rewrite this as 81 to the 5/6 plus negative 1/3. Okay? So I'm keeping the base the same and adding the powers. Now, this is where we have to involve all our other math rules. How do we add 5/6 to negative 1/3? Yeah, in order to add fractions, add or subtract, we have to have a common denominator. So I'm going to rewrite this problem again. What can 6 and 3 both go into? 6, yes? So that means 5/6 gets to say 5/6 plus that 3 is going to become a 6. How does 3 become a 6? Multiply by 2. So what do we do to the top? Multiply by 2, right? If you multiply by 2, 1 times 2 is 2. And realize it was a negative, so we're going to keep it as a negative, right? Okay. Can I add those fractions now? What is 5/6 plus negative 2/6? 3/6. So now I have 81 to the 3/6. What do you know about 3/6? It's 1/2. So now I have 81 to the 1/2. My thought would be go as far as you can. I know something here. We learned something here yesterday. What do you know about 81 to the 1/2? Okay, this is equivalent to 81 being under the radical, and since the 2's in the denominator, this is a square root of 81. Do we know the square root of 81? Yeah, the square root of 81 is 9. Okay, so I'm not going to say you always have to put it back to radical form, but you want to consider radical form. Okay, the idea that I can do the square root of 81 means I definitely want to keep going. I don't want to leave it as 81 to the 1/2. Okay, questions? Okay, of course, every problem's a little different. I'm just going to try and review the rules and hope I am preparing you well enough for homework. Trying here. So, as we look at B, 2a to the 1/3 times ab to the 1/2 raised to the 2/3. Any thoughts about where we might start on this one? Because there's several things happening. Okay, so there's going to be a couple of things going on. Eventually, we're going to have to put things together, but for right now, this 2/3 outside the parenthesis, what's it go with? It's going to go with the a, and it's going to go with the b to the 1/2. Does that make sense? So something outside those parentheses goes with each, power outside goes with each piece. So I'm going to keep I'm going to go over here so I have a little more room. My 2a to the 1/3. I'm going to just keep, that's 2 times a to the 1/3. Now, what's this a going to become? It's going to become a to the 2/3. And what about the b? What is that doing? I'll do a side note over here. It's b to the 1/2 raised to the 2/3. So what are we going to do with that? That's going to be a power of a power, where it's a power raised to a power, so we're going to multiply them. So we've got to ask ourselves, what is 1/2 times 2/3? I heard it somewhere, I think. 1/3. 1/3? Okay. And I don't know what you guys do. Some of you are going to multiply across and you're going to tell me 2/6, right? But you know not to leave it as 2/6. My brain says, oh, I can cross cancel the 2's and I'm left with 1/3. Okay. One way or another, you get to 1/3. So then this is going to be b to the 1/3. Are we good? Okay. Now what? What goes together? A and A go together? Okay, so, and you can think of this as 2 times a to the 1/3, but the key right here is I have a to the 1/3 and a to the 2/3. That 2 out front's just going to stay 2. The b to the 1/3 is just going to stay b to the 1/3. What happens with these a's? The bases are the same, and we're multiplying, so we're going to keep the base the same, and what? We're going to add, aren't we? 1/3 plus 2/3 is, I wrote 3/3 for the moment, but yes, if you see that, please write 1. Don't take that extra step with me if you don't feel the need. I'm going to clean it up, don't worry. You cleaned it up already? Perfect. So are you with me when I say it's 2a to the 3/3 b to the 1/3? Okay, and that's because if you want the side note up here, 1/3 plus 2/3 is 3/3, right? Okay, now clean it up. I have 2a b to the 1/3. Now what I should have done this morning is I should have checked to see how the directions read in Savas. What's the other way to write this? What could this 1/3 power be written as instead? A cube root. Now, what's the 1/3 power on? The b. So what's the cube root go on? Just the b. So the other option is we could write this as 2a times the cube root of b. Now, which is more simplified? There's not an easy, clear answer for that. In my notes, I have that either of these answers are good. Honesty, I forgot to go back and remind myself of what Savas expects. Okay? So you'll have to watch the directions for Savas and see what they say. Okay? Sometimes it's getting it wrong to see what they want in what form. Okay, but those are pretty equally, simplified. And there's always a chance Savas takes both. Questions? Okay. Are these exponent rules coming back to us at all? Maybe they never left us, but I don't know. They always seem a struggle. Okay, C. X to the 7/8 y to the negative 3/5 times x to the negative 4/3 times y to the 3/5. Thoughts on where to start? Go for it, Patrick.
Could our y's just cancel? Because there's negative 3/5 and positive 3/5.
Okay.
Cancel those.
And why are they going to cancel? I'm agreeing with you. Because what are we going to be doing with those exponents? If we've got all these pieces being multiplied, what do you do when bases are the same? You add the exponents, right? And so I'm going to take a step to get there. But yeah, our y's are going to drop out here in a moment. Okay, I'll walk you through the y's, the reasons. Now, my recommendation is we rearrange this. My thought is to rearrange this so you can see the pieces, but realize I have x here and x here, yes? This is all multiplying. This is just 4 terms being multiplied. And so with that in mind, if it's x to the 7/8 times x to the negative 4/3, I can rewrite this as x to the 7/8 plus negative 4/3. Because I'm keeping the base the same. Since it's multiplication, we're adding the exponents. Can we also do the same thing with the y's? The base of y, it's multiplying, so we're going to add the exponents. So negative 3/5 plus 3/5. Okay? Now, what about the x's? Okay, in order to add 7/8 and negative 4/3, we need a common denominator. What do 8 and 3 both go into? 24? Eight times what is 24? 3. So 7 times 3 is 21. 3 times what is 24? 8. So 4 times 8 is 32. There's still a negative there, right? What is 21 24ths plus negative 32 24ths? Negative 11 24ths. Okay. What about the y's? Negative 3/5 plus 3/5. Officially is what? Well, it's 0, right? What is anything raised to 0? A 1. Do I need to write 1? No. And that's where when Patrick used the phrase cancel it out, they do essentially cancel out because y to the 0 is 1, so we just don't write it. Okay. I will tell you, x to the negative 11 24ths will not be an acceptable answer because there's a what? A negative exponent. How do I get rid of a negative exponent?
1 over.
Take it to the denominator. So it's 1 over x to the positive 11 24ths. Now, on this one, I just have this as my answer. Okay? I don't have a radical option in this one. Could we do a radical option? Technically, we could. We could say what? 1 over the 24th root of x to the 11th? Kind of overkill. Okay? In a situation like this, I don't think you'd see radical form. I think you would just see it like that. Absolutely do not leave a negative exponent, though. Okay? Stop me with questions as you have them. But I'm sure the harder part is when you have to do this on your own, right? And I don't have you leading you, I'm not leading you through the exponent rules. Okay, let's look at D. A to the 3/2, B to the negative 4/3, all raised to the 4/5. What am I going to do? What? Power of a product? Yep, I agree. This 4/5 goes with what? Goes with the A to the 3/2 and the B to the negative 4/3. Okay? With that in mind, this also kind of goes along with power of power in that on this first piece, try to decide how I want to write this. It's A to the 3/2 and then raised to the 4/5, yes? That's what you need to visualize. And if it's that 4/5 goes to 3/2, it's A to the 3/2 raised to the 4/5. What am I going to do with the 3/2 and the 4/5? What do we say? We're going to multiply them because it's a power raised to a power. So we're going to multiply those. So this is going to become A to the I personally cross cancel. 2 and 4 both divide by 2. 2 divided by 2 is 1. 4 divided by 2 is 2. When I multiply, that's going to give me 6/5. And then we have B. This is B to the negative 4/3. Also raised to the 4/5. Okay, a power raised to a power. What are we going to do with these powers? We're going to multiply. Negative 4/3 times 4/5. I don't see cross canceling, so this is just going to multiply and be what? 16. -16/15. So this is going to be B to the negative 16/15. Okay. Thoughts on where to go next? Can I put these exponents together? And the answer is no, because they have different bases, right? So they have to stay separate. Can I leave this as my final answer?
No.
No, because there's a negative exponent. Savas will definitely balk at that. How do you get rid of a negative exponent?
Make it the,
Move it to the denominator. Does everything move to the denominator?
no.
No, only what has the negative exponent. So, what's that saying? A to the 6/5 is going to stay on top. B to the negative 16/15 is going to move to the denominator, where it can be B to the positive 16/15. And it's not pretty, but that's how I'm going to leave it. Radicals isn't going to make it any prettier, if I can talk about that. Okay, so I'm going to leave it like that. Okay. E. I feel like I kind of left off a rule up top now that I think about it. X, y to the third over x to the 1/2, all raised to the 2/3. What's your brain telling you? What about that 2/3?
That's true.
Okay, it's going to everything, yes? Okay, so even though it's a fraction, it goes to everything, top and bottom. So that means this 2/3 is going to go to the x, it's going to go to the y to the third, and it's going to go to the x to the 1/2. Okay, so it's kind of like power of a product. I really should have a power of a quotient on here, and I don't know. I didn't think about putting that on there. It goes with everything. So, on top, we're going to have x to the what? 2/3. Y to the what? What am I doing with those powers? We're multiplying them. So you're going to multiply 3 times 2/3. What happens when you multiply 3 times 2/3? 3 is 3 over 1. The 3's can cancel, and you're left with 2. Okay? Denominator. X to the what? What are we doing with 1/2 and 2/3? Again, we're going to multiply. 1/2 times 2/3. 2's cancel. What do we have? 1/3. Okay, where next?
We cancel the x whenever I cancel the
Okay, yeah, I wouldn't use the word cancel the x's because we're still going to have x. But do we need to put them together? Yeah, okay. I don't know if we used this rule today. We used quotient of powers today. I'm not sure if we have. But these x's have the same base, yes? When the x's have the same base, you're going to keep the base. And what are you going to do with those exponents? Since it's division, you're going to subtract. So we're going to be doing 2/3 minus 1/3. Kind of connected to my subtraction sign there. What is 2/3 minus 1/3? 1/3. So I have x to the 1/3. Now, when you do 2/3 minus 1/3, that takes it out of the fraction. So that's just x to the 1/3. And what else did we have here that was on top already? Y to the second. So the y to the second just carries down. There's no, if there are other y's, we put the y's together, but they aren't. There aren't. So we just carry it down. X to the 1/3, y to the second. Nothing else to put together, nothing else to raise power to power. I actually have two options, kind of like what I had up on B. I have two options for answers. I have this as a possible answer. And I think just because it's an easier one, or how could you rewrite x to the 1/3? It would be that 3 in the denominator says it's a cube root. So now, if I did this, I would put the y squared out front times the cube root of x. And the reason I would put the y squared, you tend to put the non-radical pieces out front, is so they don't accidentally look like they are part of the radical. Okay? So either or. I know none of these answers are satisfying final answers in a way. We want to go farther, but we can't. Okay? The challenge, as I said, is keeping all your exponent rules straightened out. Okay, one more. F. Okay, where are you starting? What'd you say? Okay. We're going to take the 1/2. It goes with all the pieces. So it goes with the 3 on top, and it goes with the 32 to the 2/5 on bottom. So the 3, it's going to have a 1/2 power now. So that's 3 to the 1/2 over 32 to the what power? 1/5. It's a power raised to a power, so we multiply. 1/2 times 2/5 is indeed 1/5. I would encourage you to go another step and think about radicals here. Okay? I mean, right now, I cannot put these together. They are not the same bases, right? 3 and 32 are not the same bases. What is 3 to the 1/2 rewritten as? Square root of 3. What is 32 to the 1/5 rewritten as? Okay. 5th root of 32. And that right there is why I say go one more step and think radicals. Because if your brain is saying 32 to the 1/5, you're probably saying, I don't know. However, I would hope after yesterday that if your brain sees the 5th root of 32, you know that goes farther. Maybe. Okay. What is the 5th root of 32?
2.
It is 2. What's the square root of 3? Some lovely decimal that we're not going to talk about. So, square root of 3 over 2 is about as simplified as you get. I would probably leave it as square root of 3 over 2, although I will tell you, I have an or if you wanted to go back and say 3 to the 1/2 over 2. That is equivalent. I think it's kind of annoying going back to that form. I think this is a simpler form, but we need to be flexible and understand the connections too. Okay. That's what we got, folks. Okay. Work to freshen up on your exponent rules. Work to keep them straight. Okay, that's where the practice is going to be. So we're going to have a homework with each of these parts. So there's lesson 5-2, part 1 that should be available in Songbird today.